8. A hardware store sells many items, including hammers, nails, and planks of wood. The probability that a customer buys at least 5 nails and not a plank of wood is 0.02, okay? Which is 1/50th, or I guess you could say 200th, if you're someone who likes fractions. I like fractions, but no, not if they're obnoxious fractions. Okay. On the other hand, the probability that a customer buys 5 or more nails and also buys a plank of wood is 0.28. Suppose that no customer who buys a hammer buys fewer than 5 nails, and that each customer has a probability of 0.2 of buying a hammer. What is the probability that a customer either purchases a hammer or buys at most 4 nails? Okay. So there's a lot going on here. Hammers, nails, planks of wood. What I might do is start to make some events. So H, this is the event that a hammer is bought. W, that'll be the event a plank of wood is bought. And then there's N. Now, when they talk about nails, it's not that a nail is bought or not. There's only 2 things that are talked about when it comes to nails. At least 5 nails are bought, or at most 4 nails are bought. Okay? And these, as we might remember from some of our counting problems, are the exact opposite of each other. If I've got at least 5 nails, I've got 6, 7, 8, 9, 10, some number of nails. If I've got at most 4, I have the numbers that I didn't just list out. 0, 1, 2, 3, 4. Okay? So we'll let one of these, we'll say at least 5 nails. Okay? We'll let one of these be event N, and so immediately I know N complement is the event that at most 4 nails was bought. Okay, so a little tricky in our language problem, but there we go. Okay. So, what else do we have? So now we've got our events. Let's start talking about some probability here. Okay. Probability the customer buys at least 5 nails and not a plank of wood. They buy at least 5 nails and not a plank of wood. 0.02. Okay, probability that the customer buys at least 5 nails or 5 or more nails and buys a plank of wood. Okay, so we can translate that. 0.28. Now, just as I'm thinking about this, we've seen this a couple times before. And intersect not something, and intersect something. If I add these up, I should just get the probability that somebody buys at least 5 nails. I don't know if that's going to help. So when it comes to decimals, I should probably write this out. Okay. Because we don't get calculators, no calculators for you, you may find yourself adding decimals old school. So 2 plus 8, 0, carry the 1, 1 and 2 is 3, nothing to carry. 0.30, or we just say 0.3. So I don't know if that's going to help, but that's definitely something I've noticed because I've been working with my formulas. Okay. So, just keeping track, we have used this piece of information, and we've used this piece of information. What else have we got? Suppose that no customer, so that to me suggests this will never happen, and when we think things that never happen, that's a probability of 0. So no customer who buys a hammer buys fewer than 5 nails. So that would be at most 4 nails. Okay. So the probability, what they're saying there is the probability of if I'm a customer who's bought a hammer and I haven't bought 5 or more nails, probability of that happening is a 0. Okay, nice little coded information there. Okay. And now what else have we got? Each customer has a probability of 0.2 of buying a hammer. Okay, so no extra attachments. They're not telling me about planks of wood and hammer or anything like that. Probability of buying a hammer is 0.2. Okay. Now, just because we had just seen it and combined these to get 0.3, maybe I'm thinking, oh, hammer is hammer and buying at least 5 nails, and hammer and not buying at least 5 nails. This one's 0.2, this one's 0. So I am able to figure out that the probability that somebody buys a hammer and at least 5 nails is also 0.2. I've worked out something else. Again, I don't know if this is going to help, but it's something I'm noticing. And rather than saying, here's all the information, what do I do with it? Looking at things and combining them as you go can certainly help us out. What is the probability that a customer either or makes me think union, either purchases a hammer or buys at most 4 nails? Hammer or not my nail event. So that's going to be what? The probability of H plus the probability of N getting the right number of nails minus the probability of their intersection. Well, I know their intersection, and I know the probability somebody buys a hammer, and hey, I was working at it the whole time. I know the probability somebody buys a nail. So this is just going to be... Oh, sorry, this should be n complement. My mistake. 0.2 plus... Ooh, I don't know n complement. I worked out n. But we remember one of our formulas tells us how to get. So both of these 0.2s are here. Probability of n complement is just 1 minus the probability of... Oh, this should be an n complement as well. Okay, sorry. Putting some numbers together in the wrong spots. This one is a 0. So 0.2 plus 1 minus the 0.3 we worked out before, minus 0. 0.2 plus 1 minus 0.3 is 0.7. 0.9 or 90%. So the probability somebody buys a hammer or at most 4 nails is 90%. Just playing around with our probability formulas.